Hi guys, this recording is for section 4.1 example 6b, okay? Remember example 6b, you were supposed to write down the steps and follow these steps when you guys are doing your homework. So when the homework says use steps 1 to 8 to analyze the function, I want you to take out your notes and use these steps, okay? So step number 1, according to your notes, determine the end behavior of the graph of the function. So the end behavior, and if I were you, I would obviously write down the steps, okay, and write end behavior. So just keywords, okay? And looks like I can't even spell the word end behavior. All right, end behavior. So that way you know in your mind what you're looking for. So the end behavior is the key term, right? When you write it in descending order, it's the highest term. Now, when you have it already factored, then what you do is you multiply all of the first term of the factors, okay? So in this case, I have 3 factors. So when I multiply them together, I would have x squared times x squared is now x to the 4th. So when you multiply, you add the exponents. And then x to the 4 times x, that's x to the 5th, okay? So end behavior, it's a function, and that's x to the 5th. Step number 2, let's go back and look what step number 2 says. Step number 2, find the x and y intercepts, okay? So x-intercept is y equals to 0, so I will take y, set it equal to 0. You know, what's really nice about this is that this function is already in factor form. So what I would just do is take each factor and set it equal to 0, okay? So here are all the 3 factors. We're just going to take each, set it equal to 0. X squared equals to 0, meaning that x has to be 0. Okay? X squared plus 1 equals 0. So x squared equals to negative 1. Subtract 1 from both sides. What you need to do now is take the square root. Okay? Well, when you take the square root, the radical, whatever's under the square root or the radical, can't be negative. So there is nothing here. You can't take there is no x-intercept at that particular location. Now, x-intercept meaning it has to be a real number, okay? Because if it's not a real number, it's not going to cross over the x-axis. So when you're looking for x-intercept, it has to be a real number. So the next x-intercept is we are going to subtract 4 from both sides. So those are my x-intercepts. Now, y-intercept is when x is 0. So I'm going to use a different color. So y equals, every time I see an x, I will now put in zeros, okay? So 0 plus 4. Well, what's happening is, what is 0 times anything? 0 times anything, it's 0. So in this case, x-intercept and y-intercept happen to be at one location. So I'm just going to write them all together and I'll box it up, okay? So 0, 0. This happens to be both x and y-intercept, so I don't have to write it out twice. And then there's another x-intercept at negative 4, 0. So those are them. So what is our next step? Okay. Step 3 says determine the zeros and their multiplicity. Use this information to determine whether the graph crosses or touches the x-axis. So I have 2 zeros, so step 3, okay, step 3. It's looking for the zeros and its multiplicity. So the zeros are x equals to 0. Well, what multiplicity is this? Well, look at this one. It's a multiplicity of 2 because when we found x equals to 0, it was originally x squared equals to 0. So this has a multiplicity of 2, okay? Now, how about the negative 4? Well, that's my second 0, x equals negative 4. How did we find that? Well, it was just x plus 4 equals 0. So that just has a multiplicity of 1. Okay. And then it says, hey, tell me whether it crosses or touches at these 2 locations. So the graph crosses, okay? It crosses at all odd multiplicity. Crosses at x equals negative 4 and, okay, touches at x equals to 0. So these are all part of the answer. So I don't have to highlight anything because the entire thing is part of the answer. So what is my step number 4? Step 4, create a number line to find points on the graph around the x-intercept. Okay, so on example 6a, we created a number line and used the x-intercepts, right? Okay, so here's number line. I have 2 zeros. One's -4, one is 0. It doesn't have to be a perfect equal distance. It just have to have numbers on it. So remember, we were trying to find where it was positive or negative. So I will always pick some ginormous negative numbers, okay? And then I'm just going to plug it in. Okay, where do I plug it in? I plug into the original, of course. So here is your original. Let me highlight it maybe in a different color. How about green? Okay, so here's your original. So I'm going to plug in -100. So when x is -100, there are 3 different factors here. So you have, let me just zoom in out a little bit so I can see. So you have a -100 square, okay? Then you have a -100 square before you add a 1. Then you have a -100, plus a 4 inside this last quantity. So I'm just really looking for positive and negatives. I'm not interested in what the actual answer is, right? -100 square is positive. Okay, -100 square is positive, plus 1 is still positive. Oops. Okay, then -100 plus 4, that's a negative. So a negative times a positive answer is going to be a negative. So over here on the left hand side of -4, it's going to be positive. What does that mean? That means y is, positive. I wrote negative. I'm sorry. On the left hand side of -4, it's negative. What does that mean? That means y is going to be below the x-axis. Okay. Then the next one is I'm going to pick a value in between -4 and 0. So I'm going to pick -1. So I'm going to plug it back in, just like what we did there, right? So -1 square is positive. And if you know it's positive or negative, you don't have to really write down the number. I'm not interested in the actual value, the y value, when x is -1. I'm just interested in, hey, is it positive or negative, okay? So -1 square, okay, -1 square is positive. Positive plus 1 is positive again, okay? -1 plus 4, that's positive. Okay, you have 3 positive multiplying each other, you're going to get a positive. So what does that mean? It means that in between -4 and 0, the y value will be above the x-axis. And then I'm going to pick something ginormous on the right, okay, like 100. So when x is 100, 100 square is positive, okay? 100 square plus 1 is positive. Oops, I just want to write positive. 100 plus 4 is positive, okay? So all of that multiplied together is a positive number. So when y is going to be above the x-axis on the right side of 0. So that's all we are doing with step 4, okay? Now step 5, let's see what step 5 is saying. Approximate the turning point using the calculator. Okay, I can't get the calculator on here, so I'm going to use decimal. So let me go and see if I can pull up decimal. Okay, decimals. Here we go. Okay, so let me see. I think it was x squared times, it was x squared plus 1, right? Plus 1, and then times, it was x plus 4. Let me just double check really quickly, okay? All right, let's go back and check my equation. X squared plus 1, x plus 4. Okay, looks good. Then I'm just gonna quickly move this so I can see all of, oh my gosh, look how tall. Oh, look at that. Okay, so I'm gonna move this. I'm going to stretch out the x-axis, but at the same time, I want to see the max and min. Okay, so look at this. The y value looks like it shoots, oh my gosh, it's like higher than 90. So when you are using this, make sure you use zoom fit. X min and x max, okay, if you're graphing this out on your calculator, so this is step 5. Step 5, okay. approximate the what? The turning points? Approximate the turning points. Okay, so turning points using a calculator. Turning points. So make sure your x-min, okay, what is the smallest x-intercept that you had? It was -4. So x-min, make it -5. And then x-max, you had a 0, so make it 1. You want to go on the left and right a little bit, okay? And then do zoom fit. So always, and then it should give you a nice curve. Okay, so let's see. Based on my Desmo, my first turning point is this one, okay? -3.17 and 92.15. Okay, I'm just going to use 2 decimal places. So my first turning point, -3.17, comma, 92.15. Let's double check my values. -3.17, 92.15. Great. And then my second turning point is right here in the bottom. So it's 0, 0. Beautiful. That's even easier. So I have 2 turning points. Okay, 0, 0. So those are them. Now, what is step number 6 say? Step 6, use steps 1 to 5 and graph the function by hand. All right. So it looks like step 5 is the only one that you're using the calculator for. Everything else is kind of given to us. Okay. All right. Because y is 90 something, I'm just going to scale this by 10. 10, 20, 30, 40, 50, 60, 70, 80, and I even need to extend it even a little bit more. Oh my. Okay, 80, 90. So this is 90. This is 10. X, I can definitely keep it by 1, so I'm okay with that. If it's by 1, I don't need to label it, okay? So step 1, the end behavior. I don't have to graph that out. Step 2, I have the x-intercept at 0, 0. Y-x-intercept at also -4. So those are my 2 x-intercept. The y-intercept is also at 0, 0, so I don't have to plot that again. Step 3, it crosses or touches. Okay, so we will verify that. Step 4, it's telling me that on the left-hand side of -4, the y is negative. So that means I'm starting here. Okay. Then it says in between -4 and, let me highlight this for you. In between -4 and 0, my y value should be positive. So what does that mean? That means I'm just going above. Okay, wee, like that. Okay. Then it says, hey, you know what? On the right side of 0 is also positive. So what does that mean? That means I'm going back up. Okay, wee, like that. Okay. Oh wait, you know what I forgot? I forgot to plot my. Ooh, that was a big typo. I forgot to plot my turning point. -3, 1, 2, 3, and 92. That's why we found it, right? 92 is right here. So I'm going to go straight all the way up there. So let me regraph that. Sorry, I got too excited. All right, so my turning point, oops, why did I erase that? 92, -3.17 and 92. And the other one's at 0, 0, so that's okay. So similarly, so we're starting it down here because that's where, and then the turning point's all the way up here. Oh man, is that a little bit off? It's not going to connect. I'm trying to make it nice and it's not connecting for me because the scaling is really different. So, all right, let's try this again. We're starting at the bottom, we're crossing over the x-axis, we're going up to meet the turning point. It's going to be one ugly graph here. Make this fat. There you go. All right. And then I'm going to touch my x-intercept at 0, 0, and then I'm looping back up. Okay. I have 2 turning points. One is right here, -3.17, comma, 92.15. And then the other turning point is 0, 0. It happens to be my x-intercept and it happens to be my y-intercept. This dot right here, I'm making it fat because the scaling is so different that it's not going to line up. But look, it looks pretty good. Now, what is step 7? Step 7 says, find the domain and range. Okay, we can totally do this. So step 7, domain is all rails, right? And range is, what is the range? The range is also, you fill that out, okay? If I don't see that you fill, and when I stamp your assignment and this is not filled out, I can't give you your stamp. So if you are listening, you should be filling it out. Unless you are not listening, then you don't know what I'm saying. Step 8, what is step 8 asking? Step 8 is going to ask, determine whether the function is increasing and decreasing. Okay, so increasing, can't spell increasing, here we go. Increasing. So when is it increasing? It starts down here and then it stops right there, right? So it's going to be from negative infinity to that x value, which is negative 3.17. And then it also increases from here to there. So also from 0 to infinity. So those are the two increasing places. When is it decreasing? It starts there and it ends here, okay? So decreasing is, let me write that down, decreasing. Okay, it's from negative 3.17 all the way to 0. And I believe that's the end of all 8 steps. Let me pinch it in so you can have the whole thing on one screen. There you go. All right, this is the end of our video notes today. Bye-bye.